This is an experiment to measure the resistivity of a wire. You can see we've got the wire sellotaped down, there it is, look, the wire, to a long meter ruler. At the moment there's quite a few kinks in that wire. We may need to get rid of the kinks in the wire by stretching it a little bit to be super accurate, but for the time being I'll just leave it stuck down there. We have a crocodile clip at either end, and the crocodile clip is connected in a normal circuit. What is the normal circuit? Well, the normal circuit is a power pack. I often use batteries instead of a power pack, but a power pack is perfectly fine. The power pack here is set on 4 volts. 4 volts is plenty for this experiment. Obviously DC, not AC. In series there is a variable resistor for altering the current, and an ammeter in series as well. So when I alter the variable resistor, you can see the current changes in a predictable fashion. Connected across the wire here, and you can see the voltmeter. Look, there's the wire to the voltmeter. This voltmeter is connected in parallel with the wire. So all we do to take measurements on this is we select a length using the crocodile clips. When we select a length, I'm using 1 meter at the moment. We take a reading for the voltage and the current. If I'm being super accurate and want to take good readings, I would then take a range of voltages and currents for that length of wire. Take a range by altering the variable resistor a few times, each time measuring the volts and the current. I would then plot a graph of V against I for that length of wire, and that would give me the gradient of that graph, would enable me to determine the resistance of the wire. I can then vary the length. So varying the length of the wire is a matter of just unplugging the crocodile clips and changing the length of the wire. I've made it about 85 centimetres and repeating. Now the difficulty with this is many people, when students do this, they often make the length of wire too short. They'll use say 10, 20, 30, 40, 50. That's ineffective because this experiment is really only going to measure the resistivity if you keep the temperature of the wire constant. And if you use a very short length of wire, the wire is going to heat up very rapidly. If I do a very short length of say 10 centimetres, that's 20 centimetres actually, isn't it? So I could probably do even shorter than that. So let me go to 10 centimetres of wire there. At 10 centimetres of wire, there's a current. The wire is going to heat up quite fast, and as it heats up, its resistance will go up. And it's not going to give us a good value for the resistivity. So I would recommend always do as a minimum length of wire 50 centimetres, and do 50, 60, 70, 80, 90. Never go below 50. Okay, hope that was helpful.